Welcome back, engineers. Today we will learn about response spectrum analysis. This is the linear dynamic statistical analysis method, which measures the contribution from each natural mode of vibration to indicate the likely maximum seismic response of the essential elastic structures. The response spectrum analysis are widely used in civil structure designs. The two major examples, the high-rise buildings under the wind loads, nuclear power plants under the design seismic loads. There are three methods to available here: the square root of sum of the squares, the complete quadratic combination, the Rosenblueth double sum combination method. In the second slide, we will discuss some important points. The first point is that the excitation is applied in the form of response spectrum. The response spectrum can have displacement, velocity, or oscillation units. For each spectrum value, there is one corresponding frequency. The excitation must be applied at the fixed degree of freedom. The response spectrum is calculated based on modal and response. If the response strain stress is of interest, then the modal strain and the modal stress need to determine in the modal analysis. In the problem statement, today we will discuss the analysis of 3D hinge, in which the material we will assign static structure by default, the element size 1 mm, the fixed support at one end, the maximum modes to find 2, RS oscillation in y direction. Use the following plot of frequency and oscillation. In the output we will find the direction deformation and the von Mises stresses. First of all, we analyze modal analysis. After that, we analyze response spectrum analysis. Click on geometry. Wait some time for open the tab. Click on File, click on Import the geometry, select the model from our design library, select Open and say Generate. As we see that there is no mistake in the model, so click on Model, wait some time for open the tab. As we know that the response spectrum analysis is similar to the response vibration analysis. Both are follow the mode superposition method. So we will combine the data from modal analysis to the response spectrum analysis. So wait some time for open the tab. Click on response spectrum analysis, click on geometry, engineering data and the solution, and combine with the response spectrum analysis. Go through the mechanical, click on mesh, give the element size 1 as per the problem statement and say generate. As we see that the elements are good, so go through the analysis setting, give the mode shape 2 as per the problem statement, click on model, click on insert, click on fix support, click on the one end and say apply, click on solution and say solve. Wait some time for open the tab of the output. As we know that in the second part, click on Analysis. Select the method SRS, COC and rows. Click on Calculate Oscillation as per the problem statement. Click on the response spectrum. Insert RS oscillation. Click on boundary condition. Select all the fixed supports. Give the direction Y direction. Select all the data and put it in the tabular data. At the first, second and the fourth, the oscillation and the frequencies we put it in the tabular data. So wait some time to put it all the data in the tabular data. The first frequency is 1 Hz, second one is 500, third one is 1000 and fourth one is 1550. Click on Solution. Insert total deformation and the direction deformation. Click on Stress. Click on Equivalent von Mises and say Solve. In the output, the total deformation we find out 5.31, the directional deformation we find out 4.946 maximum, and the equivalent von Mises stresses find out 5.9572 maximum. Send your doubts in the comment section. Stay home, stay safe.